This example asks us to find the definite integral from 3 to 7. So you know it's a definite integral when you look down at your problem and you have bounds on that integral symbol. So a lower bound and an upper bound that are numbers. From there, we're taking the antiderivative of this equation, 2 to the 9x dx. So the 3 to 7, the antiderivative, that's just saying take the antiderivative of this piece, and dx is just telling us the variable that we care about. So really those are just directions telling us what to do to the equation in the middle. What you're looking at here is what I refer to as a special case antiderivative. Special cases in my language mean things you have to have memorized. So you had a bunch of derivatives you had to have memorized. So your sine, cosine, tangent derivatives, your log derivatives, your natural log derivatives, and your exponentials, which is what we're looking at right now. So all of those things you had to memorize the derivative of, guess what? You're going to have to memorize the antiderivative. So going back the other direction. What we're looking at here is the antiderivative of an exponential equation where we have a number raised to and then a number times x. I really recommend memorizing this with the number times x piece inside here. It's huge for just kind of saving you some work on some other problems. The antiderivative of this that we need to have memorized, this is going to look like we'll take 1 over n, whatever that number is, times, and then this is going to be 1 over the natural log of our a value. And then from there, you're going to multiply that by a to the n times x. That piece will stay the same, and then we put our plus c at the end. So as we come through and look at this problem specifically here, our a value on this, our n value, excuse me, is 9. Our a value is 2. So putting this together, we would get 1 over 9 times 1 over the natural log of 2, and then times, and then the rest of the stuff just stays the same. So 9 to the x, 2 raised to the 9x. When we're dealing with definite integrals, we get this little evaluation bar at the end. So we're going to evaluate this from x equals 3 to x equals 7. To do that, I just call it the top minus bottom method. You're going to take the top value, plug it into that equation, and then you're going to subtract off the bottom value plugged into the exact same equation. And so out of here, we'll get 1 over, I'm just going to call that 9 times the natural log of 2, just sort of squeezing those two pieces together, times 2, and then this will be to the 9, and instead of x, we plug in that top bound, which is 7. So there's our top value, minus, and then we do the same thing with the bottom value. So this will be 1 over 9 times the natural log of 2, and then times 2 raised to the 9 times, and then instead of x, we plug in our lower bound, which is 3. And from here, you're just going to plug all of this into your calculator and get out an answer. And so out of there, you're going to get 1.478. Your calculator would probably say something like e to the 18th. That's how your calculator talks about scientific notation. You would see this more commonly written by hand as 1.47 times 10 to the 18th power. So the definite integral, the area between the curve and the x-axis from 3 to 7 of this equation gives us 1.478 times 10 to the 18th. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.